Now we have a crate being lifted up. Okay, and it's kind of an odd arrangement. Let me zoom on this a little bit so you can see it better. The crate is attached to a pulley here, and that pulley then is attached to the cables. Getting a good color here. All right, so I've got the cable. Oops. How many times has that happened? The cable pulling up here and here. So just like that. And that's all coming from the motor over here, just like that. Now that on the other side of that pulley here, there's my tension, which is my tension down here like this. So that tension that's pulling up is really 2 times the cable force. Just like so. So kind of watch out for things like that. That's a little bit tricky. I'm not sure why they decided to do that unless they just felt like being stinkers today. So, but anyway, that's what we got. Okay, and so let's get to it. We've got our change in kinetic energy. Okay, minus delta U plus whatever work is done. Okay, and we are initially at rest, so that's kind of nice. So I'm just gonna kind of do a little shortcut here and call it 1/2 mv final squared since the initial is 0. Okay, and we're going up, so we got minus mg s. Okay, s is eventually gonna make it up to 15 feet. 15 meters there. And then the work that's done. Okay, so I think what we'll do here, so that our equation doesn't become like really crazy and unmanageable, let's calculate the work done separately. Then we'll just throw it back into the equation. So that work is an FDR. Okay, the movement is up. The force of the tension is up. Okay, so what I really want to do here is turn that into a TDS. We're going to go from 0 to 15. Okay, now remember the T is 2 to the F's. Okay, and so that gives us 0 to 15, 2, and then we got this kind of crazy thing, 600 plus 2s squared ds. Okay, now then you can do that any way you want to. It's a pretty simple integral. I mean, you ought to be able to do that by hand pretty quickly, but you are welcome to use your calculator. Just make sure you say that you're doing that on the test so I'll know. Okay, and you know, be prepared. You know, you might get some professor at UT or somewhere who's like, why would you want to use a calculator on that? Just do it. Okay, so you know, be ready to do that. Anyway, the number that we get there for the work is pretty big, 22,500, and that's joules. Okay, so what we'll do then is we're going to add that in up here, 22,500 joules. Okay, just like that. Again, we're supposed to find the speed. Okay, and so we'll multiply and divide at the same time. So I'm going to have 2 gs, okay, plus 2 over m onto 22,500 joules. Okay, and anyway, then I'll let you plug in your numbers again. Again, you'll get a velocity squared. So make sure you take the square root of that before you enter your answer. Okay? Well, these are kind of short and sweet, aren't they? That's kind of nice.